In this video, we're going to walk you through the process of using the Provision Cassandra playbook in the Cassandra repository to deploy a new Cassandra cluster. And this Cassandra repository is going to show you our first example of using a new tag, one that we haven't shown in any of the other playbooks that we've shown you to date, the role tag, to differentiate the role that a given node takes in the Cassandra cluster. As is the case with the other playbooks that we've shown you to date, there is a Cassandra variables file. It has a significant number of parameters defined within it. I'm going to highlight a few of the more important ones, but this is something that you can walk through at your leisure in terms of some of the other parameters that are defined down here at the bottom. These are all properties that sit in the Cassandra configuration file. There's a YAML file that Cassandra uses to initialize the process. And those properties are actually used to set properties in that YAML file. In terms of the playbook run, our application is Cassandra. We have a Cassandra dir, which is where the Cassandra distribution is unpacked into. As you can see down here, we're focusing on version 3.11.0, and that's used to set the URL that Cassandra distribution should be downloaded from the main Apache distribution site. We have a private key path which defaults to the playbook directory. We have a Cassandra user and group that both default to Cassandra, and a Cassandra package list, which is set to the OpenJDK packages. There is a Cassandra data directory, which is where Cassandra is going to store its column families and such. And that defaults to /data, which, as you've seen in our other examples, is the directory that the data volume is mounted under if you define a data volume in the playbook run, and we do by default. There's a flag here that can be used to set up the Cassandra service so that it will not start at the end of the playbook run. By default, we do start the Cassandra process at the end of the playbook run. There's also an auto bootstrap flag that's used when you're adding nodes to an existing cluster, and we default that to false since this playbook is really targeting the deployment of a new cluster, not adding nodes to a cluster that already has data in it. There are some basic parameters here that are used to define the name of the cluster, the rack DC name and rack name, a key store password and trust store password, and these are probably parameters that you're going to want to change to non-default values for your deployment. There is a JVM heap size that's set. It defaults to 4 gigs. You could increase this for production environment. We've defined this at 4 gigs so that we can use a T2 large instance to start up our development test environments. As I mentioned, there are 2 roles in the Cassandra playbook. There's an application of Cassandra, obviously in the node map entries, but the role is different between these two. There are seed nodes, which have a role of seed, and there are Cassandra nodes, which have a role of none. And we haven't really discussed the role tag up until now, but when you are creating an instance, if the role is unspecified, then it's assigned a role of none. So we break out our Cassandra nodes into seed nodes and non-seed nodes. And as you can see, this node map will create a 6-node Cassandra cluster with 3 seed nodes and 3 non-seed nodes. And you can adjust this as you see fit in your playbook runs. And then, as was the case in the other examples we've shown you, there are a set of application security group rules that are used to actually control access to the various ports that are used by Cassandra. And you can see that there are 3 on the internal subnet and there are 3 on the external subnet. The 3 on the external subnet are used for client connections to Cassandra. The 3 on the internal subnet are used for internode communication between the nodes of the cluster and for JMX monitoring of the cluster. As I mentioned earlier, there are a significant number of flags that we set in the Cassandra config file. What you'll find when you look at these is that the property in the Cassandra configuration file is swap mode, and it's set as Cassandra swap mode here. So anything that starts with a Cassandra underscore as a property in terms of the information that we're defining will actually be used to set the corresponding property in the Cassandra config file without that underscore. So that'll help you look through, endpoint snitch by default here is going to be the gossiping property file snitch. We're setting that as the Cassandra underscore endpoint snitch as a property, just to make sure that there's no collisions between the parameters defined in the config file and the parameters that we're defining within the playbook run. As is the case with the other playbooks we've shown, there is a default config file, and you can see that it's very similar to all of the other default config files we've shown you. The data volume is set to 40 gigabytes by default. If you have a large database, you may want to increase this perhaps significantly to make a larger data volume to contain the data being managed by the Cassandra nodes. By default, we use a T2 large instance. You can increase this for performance reasons if you would like, but this is good for development and test purposes. In terms of the playbook itself, it's a little bit different than the playbooks we've shown to date. As is the case with the Zookeeper playbook, there is no dependency on an external cluster or ensemble in this playbook, but there is a dependency on two separate roles, as I showed you previously. So the first play actually creates a Cassandra and Cassandra seed host group. Again, we go through and look at the node map entries. If there's more than 2 node map entries, then we fail because there are multiple node map entries found. If there are none, we fail because we didn't find any Cassandra node map entries. But assuming we find more than 0 and less than or equal to 2, so we find 1 or 2 node map entries, these failure criteria will not be met and the playbook run will continue. The next step is to actually build those 2 application host groups. The first is the set of nodes that already exist that have an application of Cassandra and a role of seed and all the other tags that have been defined in the playbook run. The second have an application tag of Cassandra and a role of none. So that doesn't need to be specified here because that's the default. But we'll build the 2 host groups and count them. How many nodes are in the existing nodes came up as Cassandra seed nodes? How many came up as Cassandra nodes? By looking at the size of these 2 host groups that were built by the build app host groups role. If there are existing nodes, either seed nodes or non-seed nodes, and if you did not set this reuse existing nodes flag to true, it defaults to false, then the playbook run will fail here, and this prevents us from accidentally matching an existing Cassandra cluster that's already in use and already has data in it, and then in this playbook run, reinitializing that cluster with an empty set of data. This will prevent that from happening. We don't support adding nodes to the cluster out of this playbook. We're only talking about initializing. And so we don't want to reuse existing nodes that might already be out there, that might have been used for an earlier deployment just because we used the wrong set of tags when we went to create our new cluster. So assuming that we did not find any seed or non-seed nodes, and assuming that we didn't find that we didn't find more than 2 or 0 node map entries that have a tag with an application of Cassandra, then the last check we make is to see if there were seed node entries found in the node map. We need at least 1 seed node defined in the node map for our Cassandra deployment to succeed. So assuming that at least 1 of the node map entries had seed nodes in it, I've already shown you the default is to have 3 of each. Then we will go into the AWS role, as before, and create our instances. The difference here is that we need to actually create instances for seed and non-seed nodes. So this AWS role will actually create the seed and non-seed nodes, and then we go through the OS configuration for both the Cassandra seed and Cassandra host groups. That will initialize all 6 of them in our example using the pre-flight module. And then we go through and install and configure the seed nodes in one call to the Cassandra role. And in a second call to the Cassandra role, install and configure Cassandra on the non-seed nodes. And so when these last 2 plays are complete, we will have a set of 6 Cassandra nodes working together in a Cassandra cluster. So let's go ahead and create our custom configuration file. Again, I'm going to duplicate this file. I'm going to do a custom AWS custom config file. And inside of here, as was the case in the other examples, I'm going to set my private key path to /temp/key files. And I'm going to set my data flow to pipeline and my cluster to A. I'm going to stick with a T2 large instance, and I'm going to set up, I'm going to choose this specific image ID from the US West 2 region. I'm going to leave everything else in its default values. All right, so with that in place, I'm going to go ahead and run my playbook. I'm going to take out this reuse existing nodes flag. I'm going to use my AWS custom config file that I just defined. And I'm going to run my provision Cassandra playbook as a command using the shebang line that's built into it. So this is going to go check for seed and non-seed nodes. It's going to find none, so this is going to create our 6 AMI instances. You can see I created 3 seed nodes there. And now I'm going to instantiate the 3 non-seed nodes, which will all have a role of none. So we have our 6 AMIs up and running. You can see that the first 3 have a role of seed, the last 3 have a role of none. So here we're going through the process of creating those data volumes and adding the data volumes to those 6 instances. I'm going to pause here while this runs. It does take a little while to create all these data volumes. As we're going through this playbook run, you can see that these first 3 nodes all have a role of seed. They've been tagged with a role of seed, a role of seed on all 3. And that's for the .98, .190, and .107 nodes. What you'll see as we add more nodes to this is that the remaining 3 nodes to this list, the remaining 3 nodes, will come up with a role of none. And that's the default for any node that has not been assigned a role during the playbook run. And there you can see our first non-seed node with a role none. So now that our 6 nodes all have their data volumes attached, we're going to go ahead and create public internal ENIs for all 6 of those that we can attach as the external subnet F1. F0 again is going to be the internal subnet. And then we'll configure those once they're all attached to delete on termination. And we will assign elastic IP addresses to each of them so that we can access the system externally. And then we're going to add our 6 instances to the appropriate host groups, the seed and non-seed nodes. So the first 3 will be added to the Cassandra seed host group and the last 3 to the Cassandra host group. Then we just wait, as was the case in the previous playbooks, for all 6 of those nodes to be accessible via SSH. This doesn't take very long at all. Once this process is complete, we'll move on to the next play in the playbook, which, if you recall, is where we use the pre-flight role to finish the configuration of all 6 of these nodes, the OS configuration. So that's where we'll set up the internal network, we'll set up a file system on that data volume and mount it, and we will do the appropriate configuration on the SSH daemon. We'll walk through that momentarily. We gather the facts about these instances before we start the OS configuration process. And then we drop into the pre-flight role, where we configure that Eth1 interface properly, set up a default route for that Eth1 interface, and remove the default route for the F0 interface. Restart the network. Once the network's been restarted, so all that information has been picked up, all those changes have been picked up, we go in and build the file system on the devices that we attached from those external data volumes, and then mount those under /data on each of those 6 nodes. We reconfigure SSHD so that it's listening on the proper interface, and restart it. We generate a UUID that we can use for the host name, and then we set the host name appropriately using that UUID so that each of these nodes has a separate host name assigned to it. And we make sure that that persists across reboot. We stop the postfix service and remove the postfix package because we don't need it. And then we move on to the next play in the playbook. And this is where we deploy Cassandra to our 3 seed nodes, the 3 nodes in the Cassandra seed host group, the 98, 190, and 107 nodes that I showed you earlier. The process of installing Cassandra on those nodes starts with installing the OpenJDK packages, since we have to have those installed for Cassandra to work. And once we have that installed, we can go ahead and update some of the system settings. We're using templates for a lot of this. Then we create our Cassandra group and user. And we download that Cassandra distribution from the main Apache distribution site to /temp and unpack it into that opt Apache Cassandra subdirectory. We go ahead and create our /data directory and ensure that there's a logs directory. Back up the configuration files that came with the distribution and copy over a new set of configuration files using some templates that we've defined. We got to do a little bit of configuration to set up listen and broadcast addresses and RPC addresses and cluster names. And we create our service files, restart the systemctl daemon, and then enable on boot and start the Cassandra service. And that finishes the deployment for the seed nodes. Now we repeat it all for the non-seed nodes. I'm going to go ahead and open up another window over here. And I'm going to SSH into one of my seed nodes. And I can run a node tool status command. And you can see that I do have 3 nodes up and running right now. My 107, 190, and 98 nodes, the 3 seed nodes. And you can see if you're looking in the background here that this is the exact same sequence of events that we ran through for the seed nodes in terms of adjusting the OS parameters, downloading Cassandra, unpacking Cassandra, doing some configuration, and then at the very end, creating our service and starting our service. So just to walk through the sequence of events again, we created the host groups by creating some machine instances under AWS and adding those machine instances to our 2 host groups, the Cassandra and Cassandra seed host groups. We finished off the OS configuration of those, adding in the second NIC, building the appropriate data volume, mounting it under /data. We did all the important work around reconfiguring SSHD and setting up our host name to include a UUID, and then, of course, at the very end, removing that one package. And then we went through the process of deploying Cassandra first to the Cassandra seed host group, and then to the Cassandra host group. And now, if I rerun my node tool status command, you can see I have a cluster of 6 Cassandra nodes. The 107, 190, and 98 nodes are my seed nodes. The remaining nodes, the 140, 151, and 10 nodes are my non-seed nodes. So we've used a single Ansible playbook run, the provision Cassandra playbook, with a custom configuration file to deploy a 6-node Cassandra cluster. And we now have our 6-node Cassandra cluster up and running and ready to be used for whatever workloads you'd like to run through it. Hopefully you found this video useful, and look forward to seeing you on the next one. Thanks.